Hey guys, I just wanted to finish off our lesson 1 from Friday. We didn't get a chance to do this in class, but we were going over derivative rules and we talked about the sum and difference rule. We talked about the power rule and the constant rule. The last one we didn't talk about is the definition of e and e to the x. So this is rule number 5. The derivative of an exponential such as e to the x is e to the x. It does not change. The definition of the number e is a number such that the limit as we approach the value of 0, the derivative or the limit or the slope of the line at x equals 0 is 1. On our playlist, I attached a video that kind of goes into a bit more of an explanation as to what is the number, how did it, why is it important, how did they find it, and it goes a little bit into the proof of why this rule number 5, the derivative of e to the x, remains e to the x. So there's an attached video on the playlist. I think the video is like less than 5 minutes. It's not a very long video, but it goes through a little bit more detail of what the number is and some proofs around it. For today, I'm just going to do our example here. The derivative of e to the x, the exponential graph is e to the x. So when I have a function of e to the x minus x, I treat this as two different functions being subtracted. So I can call this y1 equals e to the x, y2 equals negative x. The derivative of y1 is e to the x. And the derivative of y2 is just -1. And so when I put them together, the derivative of f of x, my original function, is just e to the x minus 1. And that's it. Pretty simple example. Example 10, at what point on the curve, so I'm looking for a coordinate, x, y, e to the x is my function. Do we have a tangent line parallel? Parallel means we have the same slope to the line y equals 2x. This tells me that the slope of this line is 2, so I want the slope of my line to also be 2. So I'm looking for y prime. Now I know the exponential, the derivative of the exponential doesn't change. I want this derivative to equal 2. For what value x will this be true? Well, this is where we have our inverse rules and log rules and ln rules that come into play. I'm looking for x. I take the ln of both sides. X equals ln 2. This is the x value that I'm looking for. So my coordinate is ln of 2. And my y value, I got to put this into my original equation. Y equals e to the power ln of 2. Well, e and ln are inverses of each other, so this leaves me with the value 2 as the y coordinate. So on the graph, ln of 2, 2 is where the tangent line will have a slope of 2. I believe that's the end. So over the weekend, you should have these questions completed. I'm not going to be in class on Monday. You will have another video lesson in charge there, but if you have any questions, feel free to send me an email or ask your TOC. I'm not sure who's coming in on Monday, but they'll either be able to help you, and if not, just send me an email. Good luck, guys.